Write the common difference of an AP arithmetic progression whose nth term is given xn plus y. Given in an arithmetic progression AP, nth term is given an is equal to xn plus y. The common difference of an AP is given by an minus 1 for n is greater than 1. So we can write an is nothing but xn plus y minus an minus 1 is x times of n minus 1 plus y, that is xn plus y minus x times of n minus 1 minus y. We can simplify xn plus y minus xn minus of minus plus x minus y. So we can cancel here y and y, and xn gets cancelled, so I have only left with x. Therefore we can say common difference d is equal to x for the given AP. Write the common difference of an arithmetic progression, the sum of whose first n terms is given p by 2 n square plus qn. Given in an arithmetic progression AP, sum of first n terms Sn is equal to p by 2 n square plus qn, and then we can find sum of first one term, which is equal to a1 we can consider, which implies that s1 is equal to p by 2 into 1 square plus q times of 1, that is p by 2 plus q, and then sum of first two terms, which can be taken as a1 plus a2. So here we shall consider n is equal to 2, s2 is equal to p by 2 times of 2 square plus q times of 2, which is equal to p by 2 into 4 plus 2q, that is s2 is equal to 2p plus 2q, and then we have an is equal to sn minus 1, means nth term can be obtained by using the sum sn minus 1. So we can find the second term, which is equal to s2 minus s1, that is s2 is 2p plus 2q minus of s1 is p by 2 plus q. Upon simplifying, so we get 2p plus 2q minus p by 2 minus q. 2p minus p by 2 is 3p upon 2, and 2q minus q is plus q. So this is the second term. So we have the first term a1 is equal to p by 2 plus q, and the second term a2 is equal to 3p by 2 plus q. Then the common difference can be obtained. Common difference can be obtained from these two terms. D is equal to a2 minus a1. So which can be taken, D is equal to 3p upon 2 plus q minus a1 is p by 2 plus q, that is 3p upon 2 plus q minus p upon 2 and minus q. So we can cancel here q and q, and 3p minus p is nothing but 2p upon 2, which is equal to p. Therefore the common difference is p. If the sum of n terms of an AP arithmetic progression is 2n square plus 3n, then write its nth term. Given in an arithmetic progression AP, sum of first n terms Sn is equal to 2n square plus 3n, and we know that nth term can be obtained, nth term an can be obtained by using the sum as Sn minus 1. So we can find nth term an is equal to Sn is 2n square plus 3n minus Sn minus 1. We can use it as 2 times of n minus 1 whole square plus 3 times of n minus 1 by substituting in place of an n minus 1. In place of an n minus 1 we have to substitute, so we'll be getting this. So 2n square plus 3n minus, let us simplify this, 2 times of n minus 1 whole square, that is n square, minus 2n plus 1, and here plus 3n minus 3, or we can add 2n square plus 3n minus of 2n square minus 4n plus 2 plus 3n minus 3, and let us remove the brackets and write 2n square plus 3n minus 2n square, negative of negative plus 4n minus 2 and minus 3n and minus of minus plus 3. So we can cancel here 3n and 3n, and negative 2n square gets cancelled, and we have 4n minus 2 plus 3 is plus 1. So 4n plus 1 is the answer. That's the nth term. If log 2 power x minus 1 and log 2 power x plus 3 are in arithmetic progression AP, then write the value of x. Since we know that if a comma b and c, if a, b and c are in arithmetic progression, then we have 2 times of b is equal to a plus c. So here log 2 power x minus 1 and log 2 power x plus 3 are in arithmetic progression. So let us consider this is a, say this is b and c. So which implies here 2 times log 2 power x minus 1 is equal to log 2 plus log 2 power x plus 3. And by using the laws of logarithm, we have m times log a is equal to log a power m, and we can say log a plus log b is equal to log ab, and logarithm to the same base, suppose the base is x here, logarithm to the same base, if they are equal, then we can consider a is equal to b. So let us use these properties to solve this equation. So 2 times log of 2 power x minus 1 we can write log 2 power x minus 1 to the whole square is equal to, by using the first property, and the second log a plus log b property, so we can write log 2 times of 2 power x plus 3. So which implies since logarithm with the same base are equal, so we can write 2 power x minus 1 whole square is equal to 2 times of 2 power x plus 3. So that is 2 power x minus 1 whole square, we can write 2 power x whole square plus 1 square minus 2 into 2 power x into 1 is equal to 2 into 2 power x plus 2 into 3, which is 6. So we can write 2 power 2x, or let me write 2 power 2x, 2 power x whole square, and minus 2 into 2 power x, and again the term will come here, minus 2 into 2 power x plus 1 minus 6 is equal to 0. So which implies 2 power x whole square minus, so here minus 2 into 2 power x into minus 2 into 2 power x, we can write 4 times 2 power x and minus 5 is equal to 0. So let us consider for some time 2 power x is equal to some p. So which implies p square minus 4 into p minus 5 is equal to 0. So let us factorize this. P square minus 4p minus 5, we can also write p square minus 5p plus p minus 5, we can take p common, p minus 5 plus 1 times of p minus 5, so we can write here p minus 5 into p plus 1. So this expression we can write equation p minus 5 into p plus 1 is equal to 0. So we can say here p minus 5 is equal to 0 or p plus 1 is equal to 0, which implies p is equal to 5 or p is equal to minus 1. So we can write here p is nothing but, let us consider back 2 power x, so 2 power x is equal to 5 or 2 power x is equal to minus 1. And since we know that conversion logarithm into, suppose log exponential form, log a to the base m is equal to b, which implies m to the power b is equal to a. This is logarithmic form to exponential form. So 2 power x is equal to 5, we can write it as log, the base is 2, log 5 to the base 2 is equal to x, and here we can write log the base is 2 and negative 1 which is equal to x, but this is not possible because as per the condition, the log a to the base a must be positive above 0, so this is not possible. Therefore we can consider x is equal to log 5 to the base 2. Okay. If the sums of n terms of two arithmetic progressions are in the ratio 2n plus 5 is to 3n plus 4, then write the ratio of their nth terms. Let us consider the two arithmetic progression. Let small a and small d be the first term and common difference of first arithmetic progression, and capital A and capital D be the first term and common difference of the second arithmetic progression. It's given that sum of the n terms of two arithmetic progressions are in the ratio 2n plus 5 is to 3n plus 4. So let us consider Sn be the first sum of first n terms of first AP, and Sn dash let us consider be the sum of first n terms of second AP. The ratio is given 2n plus 5 upon 3n plus 4. And so we can sum to n terms in arithmetic progression is n by 2 into 2a plus n minus 1 into d. So by using this formula, let us write n by 2 into 2 times a plus n minus 1 into small d upon n by 2. In the second progression we have capital A, so we can write 2 times capital A plus n minus 1 into capital D is equal to 2n plus 5 upon 3n plus 4. So further simplifying, we can cancel here n upon 2 and we can take 2 common and we can write a plus n minus 1 upon 2 times of d upon again 2 common in the denominator a plus n minus 1 upon 2 times of capital D, which is equal to 2n plus 5 upon 3n plus 4. So we can cancel here 2 and 2, and let us consider we need to find the ratio of their nth terms. We know that nth term is equal to a plus m minus 1 into d. It's a general term. So the ratio of their nth terms, let us write am and capital Am, which is equal to a plus m minus 1 into d upon capital A plus m minus 1 into capital D. So to find these values, let us compare a plus n minus 1 upon d upon 2 into d as a plus m minus 1 into d. So when comparing, so m minus 1 must be equal to n minus 1 upon 2. So that is 2 times m minus 1 is equal to n minus 1, or we can write 2m minus 2 is equal to n minus 1, or we can write this as 2m minus 2 plus 1 is equal to n. So that is 2m minus 1 is equal to n. It's to get the nth terms ratio, so we need to consider n as 2m minus 1. So let us consider 2m minus 1 as n, or by substituting n is equal to, put n is equal to 2m minus 1. So in equation 1, so that we will get the numerator will be a plus m minus 1 into d, you will get, and denominator capital A plus m minus 1 into capital D, which is equal to, let us substitute here, 2 times of 2m minus 1 plus 5 upon 3 times of 2m minus 1 plus 4, which is equal to 4m minus 2 plus 5 upon 6m minus 3 plus 4. So which is 4m, 5 minus 2, that is 3 upon 6m, 4 minus 3, which is 1. So we can say that the ratio of mth terms is 4m minus 4m plus 3 upon 6m plus 1. And this can also be obtained by using this simple formula. If the ratio of the sums of n terms of two APs is given, then the ratio of their nth terms is obtained by replacing n by 2n minus 1. So here we replaced n as a 2n minus 1. Similarly, for any problem, if sum of n terms of two APs is given, then we can find the ratios by replacing n as 2n minus 1. Okay. Write the sum of first n odd natural numbers. Odd natural numbers are 1, 3, 5, 7, 9, and so on. Nth odd natural number will be 2n minus 1. Since these are in arithmetic progression, AP, whose first term a is equal to 1 and common difference is 2, and let Sn denotes the sum, let Sn denotes their sum. So we have Sn is equal to 1 plus 3 plus 5 plus and so on 2n minus 1, and since we know sum to n terms in AP is Sn is equal to n by 2, 2a plus n minus 1 into d, or we can write Sn is equal to n by 2 times of a plus the last term L. So here the last term L is equal to 2n minus 1 and first term a is equal to 1. So let us write, so Sn is equal to n by 2 into a plus means first term plus last term, that is 2n minus 1. On simplifying, n by 2 times 1 plus 2n minus 1, so plus 1 minus 1 gets cancelled, so this is n upon 2 into 2n, so we can cancel 2 and 2 and we can write n square. Therefore we can conclude that the sum of first n odd natural numbers is sum of first n odd natural numbers which is equal to n square. Okay. Write the sum of first n even natural numbers. Even natural numbers are 2, 4, 6, 8, 10 and so on. Last nth even natural number is 2n. So which is the sequence is an arithmetic progression whose first term is 2 and common difference d is equal to 2, and their sum let us denote Sn is equal to 2 plus 4 plus 6 plus 8 plus and so on up to 2n. Since we know that in an arithmetic progression sum of first n terms is n upon 2, 2a plus n minus 1 into d, or we can also write n upon 2 times of a plus l. L is the last term. So here first term a is equal to 2 and the last term is 2n. So let us substitute, which is equal to n upon 2, first term is 2 plus the last term is 2n, or we can take 2 common, 1 plus n, or here we can cancel 2 and 2 and we can write n into n plus 1. Therefore we can say that sum of first n even natural numbers is equal to n into n plus 1. Okay. Write the value of n for which nth terms of the two A.P.s 3, 10, 17 and so on and 63, 65, 67 and so on are equal. So given two arithmetic progressions, first one 3, 10, 17 and so on. So let us consider a be the first term and d be the common difference. First term and common difference respectively. And the given second one, the second sequence is 63, 65, 67 and so on. Let us consider here capital A and capital D be the first term and common difference respectively. So we have A is equal to 3 and D is equal to 10 minus 3, which is equal to 7 and general term in the first term, first sequence, let us consider an is equal to a plus n minus 1 into d, that is 3 plus n minus 1 into common difference is 7. So this can also be written 3 plus 7n minus 7, or we can write 7n, 3 minus 7 is minus 4. And in the second sequence, capital A is equal to 63 and capital D is equal to 65 minus 63, which is equal to 2, and the nth term, let us take capital AN is equal to A plus n minus 1 into capital D, which is equal to 63 plus n minus 1 into capital D is 2. So we can write 63 plus 2n minus 2. So that is 61 plus 2n. So the two nth terms are mentioned here, and now we need to find the value of n for which the nth terms of two A.P.s are equal. So given that nth term in the first A.P, that is an, is equal to nth term in the second sequence, that is capital En. So we can write 7n minus 4 is equal to 61 plus 2n. So let's take this in equation 1 and this is 2. So from 1 and 2 we can mention. So we can write 7n minus 2n is equal to 61 plus 4, that is 5 times n is equal to 65. So which implies n is equal to 65 upon 5, that is 13. So the value of n is 13, for which nth terms of 13th terms of 2 APs are equal. Okay. If 3 plus 5 plus 7 plus and so on up to n terms upon 5 plus 8 plus 11 plus and so on up to 10 terms is equal to 7, then find the value of n. So here given the ratio of two series, the numerator 3 plus 5 plus 7 plus and so on up to n terms, this series is, which is an arithmetic progression whose first term a is equal to 3 and common difference d is equal to 5 minus 3, that is 2, and hence sum to n terms we can write Sn is equal to n upon 2 2a plus n minus 1 into d, that is n upon 2 2 times of 3 2 times of 3 plus n minus 1 into d value is 2. So which is equal to n upon 2 into 2 times 2 taken common 3 plus n minus 1. So we have n times of 3 plus n minus 1, that is 3 minus 1 is 2. So n into n plus 2 is the sum to n terms of the given numerator series. And now let us consider the denominator. Consider denominator, that is 5 plus 8 plus 11 plus and so on up to 10 terms. So given series is also an, which is also an AP arithmetic progression whose first term let us consider capital A is equal to 5 and the common difference let us take capital D is equal to 8 minus 5, that is 3, and sum to n terms, let me take s dash of n is equal to, so we have n by 2 times of 2a plus n minus 1 into n minus 1 into capital D. So we can write here n upon 2, here 10 terms are there, so here n is equal to 10. So 10 upon 2 times of 2 times of 5 plus n minus 1, that is 10 minus 1 times of d is 3. So upon simplifying 2 5 times, so 5 times 2 5s are 10 plus 10 minus 1 9, 9 3s are 27. So we have 5 times 27 plus 10 37. So here 35 is a 150 plus 35 185 is the sum, the denominator. So given that the numerator upon denominator is equal to 7, given that, so let's consider this as 1 and 2, n into n plus 2 upon 185 is equal to, the ratio is given 7, which is equal to 7, or we can write n into n plus 2 is equal to 7 into 185, or 185 7 times. Instead of this we can write 185 factorization, 5 3s are 15, 5 7s are 35. So we can write here 7 into 5 into 37, or we can write 7 5s are 35 into 37 we can write it as 35 plus 2. And then comparing on both the sides, n into n plus 2. So we can say very clearly that n is equal to 35. So we can consider that, which is possible, n is equal to 35. The sum of 3 plus 5 and so on up to 35 terms upon 5 plus 8 plus and so on up to 10 terms, the ratio will be equal to 7. Okay. If mth term of an AP is n and nth term is m, then write its pth term. In an AP, general term an is given by a plus n minus 1 into d, where a is the first term and d is the common difference. And it's given that mth term, that is am, is equal to n, that is a plus m minus 1 into d is equal to n. Let us consider this in equation 1. And also given nth term is m, that is an is equal to m. So we can write a plus n minus 1 into d is equal to m. Let us consider in equation 2. So solving 1 and 2, or subtracting 1 and 2, equation 1 minus equation 2, which implies a plus m minus 1 times of d is equal to n, a plus n minus 1 times of d is equal to m. Subtracting both, a and a gets cancelled, and here m minus 1 minus of n minus 1 times of d is the common, and which is equal to n minus m. On simplifying, m minus 1 minus n plus 1 times of d is equal to n minus m. So here minus 1 plus 1 gets cancelled. So m minus n times of d is equal to, we can write minus of m minus n, or we can write d is equal to minus of m minus n upon m minus n. So the common difference is minus 1. So we got common difference value minus 1. Let us substitute, put d is equal to minus 1 in any one of the equation. Let us take equation 2 into, so we can write a plus n minus 1 into d value, that is minus 1, is equal to m, or we can write a minus n plus 1 is equal to m. So which implies a is equal to m plus n minus 1. So we got the first term, a is equal to m plus n minus 1. And now we need to find the pth term. So let us consider AP, which is equal to a plus p minus 1 into d. First term a is equal to m plus n minus 1 plus p minus 1 into common difference is minus 1. So on simplifying, m plus n minus 1 and p of minus 1 is minus p, and minus of minus plus 1. So we can cancel here, and we can give the answer m plus n minus p. Therefore pth term is nothing but m plus n minus p. Okay. If the sums of n terms of two APs are in the ratio 3n plus 2 is to 2n plus 3, then find the ratio of their 12th terms. Given the sums of n terms of two APs are two arithmetic progressions are given, whose sums of n terms are in the ratio 3n plus 2 is to 2n plus 3. Let us consider Sn upon Sn dash is equal to 3n plus 2 upon 2n plus 3, and we need to find the ratio of the 12th terms. Let us consider A12, divided by capital A12 are the terms. So we need to find this. And since we have a property, if the ratio of the sums of n terms of two APs is given, then the ratio of their nth terms is obtained by replacing n by 2n minus 1. So replacing n by 2n minus 1 means here n is equal to 12 we can use, and we have to replace here in place of n we have to write 2 times of 12 minus 1, that is replace n by 2 times of 12, that is 24 minus 1, 33. So replace n by 23 in the sum to get the ratio of the 12th terms. So therefore A12 upon A12 is equal to 3 times of 23 plus 2 upon 2 times of 23 plus 3, which is equal to, so 23 3 times 69, 69 plus 2 upon 23 2 times 46 plus 3, so we have 71 upon 49. So therefore the required ratio is equal to 71 is to 49. Okay.